Seismic binning grids perform a fundamental role in the data lifecycle of seismic trace data acquired on a 3D survey, as they contribute to the management of seismic trace data, from survey design, data acquisition, data processing, data loading, through to the selection of a proposed well location. From specifying the geophysical requirements of the subsurface imaging to reporting back the fold coverage achieved, they are key steps to ensuring the survey was acquired to meet the objectives. Introducing GeoSuite Online Seismic, a cloud-based application that offers the following functionality: survey design, trace data management for post-survey QA/QC analysis, QA/QC of 2D and 3D seismic positioning data, and map-making capabilities for all GeoSuite data. As part of the overall GeoSuite Online toolkit, this application integrates seamlessly with the other components by sharing parameters, algorithms, and geospatial data. For pre-survey activities, a seismic grid is manually created by supplying the parameter values specified by the geoscientists as to how they wish to image the subsurface rock formations. This is known as the horizontal resolution, which is defined by the dimensions of the adjacent cells along the two orthogonal axes of the coordinate system. The seismic grid is defined using a variety of parameters that include the origin point A, the survey bearing of the I and J axes, the incremental numbering, the horizontal resolution, specified by cell widths on the I and J axes, and the derived CRS to which the grid is tied. This enables each cell in the seismic grid to be uniquely referenced using either the I and J or the easting and northing coordinates over the geographic extent of the survey area. Planning seismic surveys is an important aspect of any pre-survey activity, and this is also achievable in the tool. Shown on the right are the intended pre-plots associated with the source and receiver lines of an OBN survey, and below the fold, coverage expected from the selected geometry. Also computed is the racetrack, showing the proposed line turns to help optimize the time planning of the survey being designed. Into the application database can be added multiple projects, where a project will comprise a designated geographic area over which your company operates, for example, South China Sea or Gulf of Mexico. Within each project, there may be multiple surveys, where each survey represents an individual seismic 2D or 3D campaign, and within a survey, there may be multiple datasets, with each one representing a different stage of a survey through the data lifecycle. For example, seismic grids associated with design, data acquisition, data processing, or data loading. The Properties panel displays all the parameters associated with an individual seismic binning grid and comprises those properties defining origin, orientation, scale, and coordinate referencing. Also shown are the various perimeters that describe the geographic areas where data was acquired and where there will be voids due to physical obstructions in the survey area. Seismic bin grids can be exported to a variety of different formats, depending upon the requirements of the next software application ingesting the definition, whether it be the P6 format used by the Geomatics team, shapefiles used by GIS, or load sheets used by data loaders. The exchange formats contain the same central grid description, but in a format suiting their requirements. Seismic positioning data can also be imported into the same projects from data files that are either compliant or non-compliant to one of the published exchange formats. The formats recognized include P184, P190, P111, SEG P1, and SPS file formats. Where non-compliant files are encountered, they can be imported using the text wizard, which allows the analyst to specify where in the file the important line parameters are found. The Properties panel displays all details about the geospatial data associated with every line of the 2D or 3D survey imported into the project. A series of tabbed pages are presented, where each contains different parameters and parameter values, such as line lengths, event distances, azimuths, intervals, duplicates, error warnings, and coordinate referencing. As this tool is only one component of the GeoSuite toolkit, it is designed to interface with all other components, with one example being its ability to import well header locations from the Wells tool. By connecting directly to the database of the Wells app, a project can be selected and all wells contained in that project are imported as a new thematic layer within the Seismic app. As such, the surface positions of all wells in that project can be visualized alongside any other imported datasets. Data that has been loaded, viewed, QC'd and edited is now ready to be exported. The functionality offered allows you to export the positioning data to whatever exchange format is required, related to whatever coordinate reference system you select, within sensible limits. The upper image illustrates an example of the P190 file format, whilst the one on the right is an example of the P111 format. GeoSuite Seismic by Geomatic Solutions. Understanding your geospatial data. Improve your decision-making.